Hello, everybody, and welcome to our next student Reactor Meetup. So hello to everybody online as well, and hello to everybody in the room. It's great to have you here, so thank you very much for coming down. It's wonderful to have you here. Today we are joined by three wonderful speakers. We've got Michael Olatokun, we have got Richard Conway and Darshna Shah. The latter two are actually not here yet, so we're waiting for them. We have one. Richard, hello there. And we are going to be doing a couple of really fun talks for you today. So move on to the next slide. So apologies for starting a little bit late for those online and everybody in the room. But we're going to kick off with Michael, and he's going to be talking about SkillStruct and what he does. We're then going to go into any questions that you may have. So we're going to be keeping an eye on the stream online on StreamYard as well. We are then going to have a little bit of a break for some food. So we have got Taco Bell coming for everybody in person. I'm afraid everybody online, if you're watching, you're going to have to grab your own food. But hey, we're going to have a good feast here. Then we are going to, in the break, actually, for everybody online, I'm going to keep you entertained with a video that I produced earlier today. And of course, if you are here in the room, then you can watch as well if you want to. And it's all about how you deploy a CV into GitHub Actions. That's a pretty cool one because it's all free. And I'll show you how to do that all within github.dev, which is an online editor with great connections with GitHub. And then it's going to be over to Richard and Darshna, who are going to be talking about AI for innovation. So with that, I'm actually going to hand over now to Michael, if you want to get going. And you are mic'd up.
Going to transition from this slide into my own. Give me 1 second. Cool. All right. We good? Perfect. All right, everyone. Those online and those in the room. My name is Michael Olatokun, and I'm going to be talking about the tech industry. Hopefully, you'll learn a bit about myself, some background, and hopefully take something away from this. Because for me, it's always very important when I do talks that you're able to grab something from what I do and also relate to what I do. I've been in the tech industry for about 15 plus years, so hopefully some of my insights will be able to help you on your journey, wherever you are on that trajectory. Okay, so what we're going to start off doing, actually something a little fun, light-hearted. So we're going to start off with a Kahoot quiz. Who's heard of Kahoot? Just raise your hands. Okay, most of you. So what we're going to do is we're going to do a, breaking down the industry icebreaker quiz. So this is all part of the actual talk itself. We're going to get a bit of insight into yourselves. I'm going to test your tech knowledge as well. And then from there, testing. Can you hear me okay? Okay, so what I'm going to do is essentially, test out that knowledge, also something a little bit lighthearted and fun as well. So I'm going to set that up right now. And what I'm going to do is I'm going to switch my screen to Kahoot. So those who have Kahoot, have your phones ready. I'm going to put the link on now. So let me transition this here. Okay. Those online, if you want to, if you're quick enough, you can also join as well. Okay. Okay, all right. Getting some decent numbers in. All right, is everyone in? Okay, let's be quick. Give those in the room maybe 30 seconds to try and get in as quick as possible. Okay. Okay. All right. Okay, cool. So most people are in. I'll give people maybe another 10 seconds. I should also say I do have some nice giveaways as well for first, second, and third. Thanks to our partnership with O'Reilly, we have access to resources and books. So as I do give talks, part of the reason I like doing this icebreaker is there is a little bit of a giveaway. So first person will get to choose the book, second, and then third. I'm sorry if you come fourth, it's a bit unlucky. But anyway, I think we will continue now because I've given you lot enough time. We're going to kick off. All right. If you're online and you happen to win, then we'll see if we can. Actually, I'll be honest, only people in the room really, so we'll just have to move on. Sorry, should have come to the event. All right, make sure you're ready to join. Make sure you're ready, prepared, and we'll kick off. So, who invented the World Wide Web? Wow, everyone got that right. Okay, nice one. This is going to be a tough quiz, okay? All right, so let's see who done it the fastest, though. Okay, Raveen, okay, nice one. Let's go on. Okay, 1 second left. Okay. All right, Fortran it is. Okay, most people get it right. A lot of people for Argo. That's normally the reception normally. We'll move on. Okay. Okay. Who's into crypto in this room? Okay, there's a couple. So I'm expecting you lot to get this right. Okay. All right, well, most of you got it right, which is good. Was that done? Okay. Praveen's still top, but then you've got Volva, Dragos. Okay. Let's move on. So what agile model is this? Please type your answer. Three, two, one. See what people put. Okay. No clue. It's honest. I don't know. Scrum. It is. It is Scrum. Well, a few of you got that right, which is good. Okay. Let's see what that's done now. Okay. Are there any object-oriented developers in the house? Let's see. Okay, most people got that right. Okay, that's a strong sign. Okay. Oh, okay, this is going quick. Okay. Okay, most people got that right. Okay, Python developers. Are there any Python developers in the house? Oh, okay. 8 people got that right. Interesting. Oh, JS with the huge jump. Okay, let's go. Oh, okay. Okay, a few laughs in the room, so we should all know who this is. There we go. Okay. Mark Zuckerberg. All right, what about this? Who is this? Okay, most people got it right. Who is the person on the right? On the right. Let's see who gets this right. Okay. All right. A couple people thought that was Michelle Obama. Okay, that's interesting. Janelle Monáe. Okay, Taraji P. Henson. I did say right. She's the person on the left, but that's all good. Most people got that right. I don't know if they guessed or not, but that's good. What has that done? Okay, 4 of us going up. All right, who is this? The clue is in the background. I'll give you that hint. Yes, most people got it right. Most people thought it was Alan Turing. I should say, for those who didn't know what that was, just a quick explanation. So in the background is binary, ones and zeros, and the person who came up with like Boolean and logic and all of this mathematical theory, somebody called George Booley, which was the answer. And obviously Boolean algebra came as a result of that. And so that was the subtle hint to who that was. Very important in terms of computer history. We won't probably be here without guys like Alan Turing, who most people said, and George Booley. So definitely one person to think about and note down in terms of your computing journey as well. Okay, let's move. Got a puzzle now. Some of you might be wondering what industry to get into. This might give you some hints. If you're motivated by money or whatnot, this should be an interesting one. So pull it in order, very important. If you had to guess. Okay, 15 seconds left to think. Okay, 2 people got that right. Interesting. So we've got cloud computing, we've got data science, then we've got AI, machine learning, and then cybersecurity. Kind of probably makes sense because cloud computing is more of an older industry than the other ones. And so if you think about it, because it's been more established, cloud computing, so things like AWS or Microsoft Azure, things like that, getting into that space is definitely more lucrative as well. I mean, they're all pretty good. So whatever industry you do get into, out of all of those is pretty good. But if you had to pick by order, then this is it. Okay. Again, C# is not an object-oriented language. Everyone's so focused in the room. Everyone wants to win that book. It's good. Okay. What has that done? Oh, JS with a huge jump. Okay. Okay, most popular language. Hint, it is on the image. As in the answer is on the image. Yep, it is Python, which most people got right. Okay, we're getting some movement, which is good, but Paveen seems to be holding on to top place. Okay, one for the blockchain developers in the room. Ooh, wow, okay. Normally not most people get that right, so well done to this room. Must have a lot of blockchain enthusiasts in the house. Okay, all right. Okay, 5 seconds left for those who are still thinking. Okay, it is football. All right, so now we're breaking out into opinion-based, opinion-based, opinion-based. Let's bring the temperature down a little bit. Okay. Interesting. Okay, so most people like math in the room. So in between is interesting. So the reason I put that in there is those of you who may not have a programming background, but like maths, I'll normally recommend data science as a good entry point, because with data science, it combines, more mathematical, equations using libraries and things like that, as opposed to pure programming itself. So for those who might not be comfortable with programming and more on the math side, data science is probably one avenue I'd recommend you go into. But we'll talk about this when I get into the presentation itself. Coding. Okay, interesting. So who put other I can explain? Who put other I can explain? Can you explain? Okay, okay. So you don't know yet, perhaps. So, okay, cool. All right, that's a good reason. Are you organized? Wow, okay. Feeling that energy in the room. Take a guess of what's going to come up. So in between, no, yes. To be a coder, obviously, organization is very important when you're talking about organizing, your source code, organizing your methods, your functions. It all helps when, you structure your program in a certain way. It helps when it comes to coding, reviews, and things like that. So being organized is normally a trait normally programmers are associated with. So it's why I put that question in there. Okay, let's go. Introvert, extrovert. Which one is it? So for those who might not know, introverts quite reserved, extroverts quite out there. Interesting. Somewhere in between. I think most people tend to say somewhere in between as well. I notice no one put "oh, I can explain" this time. No one wants to explain. I understand. Okay. All right. So how are you going to build from this quiz? So have a think about it. Some of the questions that maybe you got wrong, maybe some of the things that got you thinking. If you're able to think about that and type that into the quiz, just learn and build from this. So we'll get into the latter part of this whole quiz session. No. Let's see, I'm curious to what people have put. Okay, 3, 2, 1. Okay, should say it's gonna come on the screen as well. I should add. All right. All right, so what do we have? Reading more. I never say that beforehand just because people tend not to put their real answer. So I always like to keep that until it's too late. So we've got, okay, reading more, researching topics, learn many things. You like maths, that's good. Google, acquire new things. We've got some questionable emojis as well. We've got straight face. We've got learn Python, history. Who is Tim Cook? He is the CEO of Apple. It's fine, we're in a Microsoft place, so I understand why you might not know who that is. Okay, learn many things. So, okay, cool. So we've got a good sense of wanting to build on. Sorry?
Does this mean everyone gave a unique answer?
Yeah, pretty much. But as it gets bigger, if people say the same thing, that makes sense. So, yeah. So, for example, this question, this might give you an example of what I mean when I said that. So, where were you raised? I always like this question because it's like, you know, you're starting your technical journey, but where were you raised? How did that influence perhaps why you want to get into coding? I don't know. So I always like asking these questions because sometimes you get a consistent pattern. So yeah, where were you raised? Where did you grow up? All of that sort of stuff. Okay, so we've still got a few people. Okay, let's see. Okay, we've got a big rectangle here. Okay. Malaysia, okay. So I've got Malaysia in the house, okay. All right. I've got, okay, London, Chennai, Edmonton Green, Ukraine, in Azerbaijan, acquire new things. I think that was the last question. Okay, Mexico, Azerbaijan. So we've got a good mix, you know, multinational, which is great. Okay, so it's always great to just see, like I say, like how where you were raised potentially influenced why you're here today in this room. Okay, final countdown. Who is going to win? I think we know who's going to win, but who's going to be second and third? We've got a puzzle. Let's see. So put those 4 items in alphabetical order. Okay, let's see what that's done. In fact, actually, yeah, we'll do that first. All right. Let's see who's on the podium. So in third place, we have JS in third place. Second place, we got Dragos. And then first place, I think it's no surprise, we have Paveen. All right, cool. All right, so before we hand out the books, I think it's right to just explain what some of the books are. So we've got Building Microservices by a man called Sam Newman. I have spoken to him about his book in the past on my platform. It's a really good book just about how you control your code. I'll probably say this is more for maybe people who have programmed already, but just want to take it to the next step. So that's one. I wasn't sure what the level of the room was. So I've got a couple beginner books relatively, and this one's more intermediary. I have another book about real world software development as well. This is based on real development using the language Java as well. And then we have probably most of my beginning-ish books. So just learn how to code. Again, you know, the good people of O'Reilly gave me all these books. So without them, so a big shout out to O'Reilly. So it's just basically some friendly ways of, you know, really getting started in code. So first of all, I'll get Praveen to come up and then make his choice of book. All right. Round of applause. Yes, round of applause, round of applause. So which one would you like? This one? Okay. Cool. Okay. Thank you very much. Round of applause again, Praveen. Congratulations. Okay, so who is Dragos? Dragos, okay. Round of applause for Dragos as well. Thank you. All right, congratulations. Cool. Okay. Which book would you like? Real World Software Development. Java. Yes, this is Java. Yeah. Okay, fair enough. Fair enough. Okay, round of applause again. Hold on. Thank you. Congratulations. And then JS. There you go. Round of applause for JS. Well done. Thank you very much. Congratulations. That's okay. All right. Real World Software Development. Enjoy this. Enjoy your journey. Okay. Thank you. All right, people. Thank you. So that's a little icebreaker before we get into the real meat and bones of why we're here today. Hopefully you enjoyed that. And we'll now go back to the presentation. Okay. And that will disappear. Okay, cool. Now we are back. So I do encourage you to just take notes as we go through this particular segment. So the agenda, I'm just going to talk about who I am. Obviously, I've started off by just talking about the quiz and things like that, but some of you may not know who I am. We're going to talk about technology, future of technology, some of the pathways, and then our own SkillStruct methodology about it. And then I'm going to talk about SkillStruct as we get towards the latter part of our session. And then we'll do a roundup, maybe a bit of a Q&A. So let's just talk about my journey a little bit. So I started off as a computer scientist. I studied that at university. I did quite well, and because of that, I was able to get onto a civil service grad scheme. So for those who don't know what that is, it's essentially working for government. So I started off at the Office for National Statistics, then I moved into the Treasury. I worked there for a few years as a software engineer, and then I decided to move from the public sector right into the private sector. I was really interested in a concept called financial literacy. For those in the room, that's just basically just understanding things like markets, credit, debit, that sort of stuff. I was still passionate about tech, so I didn't want to leave that, but I wanted to work in an industry where I can, have an opportunity to learn that. So for those who are thinking, I have a side interest, but how do I combine the two things? One thing I found in combining my two passions is what am I good at and what am I interested at has normally led my path to where I decided to end up working. So I worked in the city again for a few years with some commodity firms, and I was again a software developer, working on websites, trading platforms like that. I'm a .NET developer, hence why you got a couple C# questions in there earlier in the quiz. And so I was doing a lot of building of systems based on .NET, so full stack developer. So this is probably, one of the most pivotal points, because this is probably where I was joined a relatively small company. So it gave me the opportunity to do many different things. So project management, testing, software engineering, of course, as well. I decided I wanted to do my own thing there, but based on a consultancy-based model. And so before I jumped into consultancy, I decided I had to join one. And so I joined an organization called Avanade. And Avanade is, a very huge organization when it comes to digital transformation. You may have not heard of Avanade perhaps, but you probably have heard of Accenture. I'm guessing those nodding their heads in the room, that's proof of that. So Accenture, again, is one of those, big five, I'd say probably in the top 3 tech consultancies in the world. And so I was there for a couple of years, working on tech strategy, digital transformation, learning all the code that I needed to not just become a great engineer, but also to work and do my own startup, because a lot of stuff I've done has been a combination of what I've done in different organizations. And so for me, learning that and learning all of that things gave me the confidence to work in an organization of my own called SkillStruct. And again, I'll come on to that towards the end. I was also doing things important to me at the organization as well. So underrepresentation is definitely important for me. So I co-led a network, a BAME network called Beyond. And there we were doing things about championing D&I, championing, helping young people, helping people in general that wanted to get a leg up in the industry. And so a lot of those things is what I try and do in my organization, try and help as many people as we can, especially those, from a background where maybe they don't have access to the resources in order to elevate their career. I've been very fortunate in my career so far, getting into places where I wasn't, able to see people like myself in those rooms. And so for me, when I created SkillStruct, that's one thing I definitely wanted to do. Okay, so that's some of the things about my journey. Some of the things in red that you see as well, some of my passion points. So, learning a language. So I've been learning Spanish for a few years. So, as we move, multinational, I think for me, it was always important for me to learn a language. I've just picked Spanish because work, to be honest, gave me opportunities to travel to Spain. but also just in general the culture. And so, learning a language is definitely something I recommend people do, just to appreciate not just coding languages, but languages, and you'll be amazed how the two are similar. So I would say, learning a language, building a community, all of these sort of stuff are my passions as well. Blogging, very important for those who are starting out, when in a way, maybe they don't know how to code, but, hopefully most people know how to write. And so, we encourage people to write blogs as well about the coding journey. It could be anything about learning Python and things like that. So basically what I'm trying to say is I try and put all my passions into what I do as a business. I think everyone should strive to be in an industry or do a profession that they're ultimately passionate about. Always say, follow your passions, not the money. Okay, let's have a conversation. So at this point, I want it to be fairly interactive. So I'll be asking questions and I'll be talking, having a conversation. So the first thing when we're talking about, breaking down the tech industry is understanding what technology is. So my first question to you lot, and you lot can have, maybe 10 seconds to think about this before I start pointing to people and having a conversation, is how would you define technology? There's no, well, maybe there is a wrong answer, but there's no crazy answer that you can say, I hope. Don't test me on that. But yeah, it could be a definition, it could be a word that comes to mind, it could be an example of what is technology. Okay, Praveen.
Something that makes your life easier.
Okay, that's a great example. Definition, I should say. Anyone else in the room have a definition? Do you have one? Pardon? Innovation, yes. Okay, anything that makes people more productive. What about this side of the room, to my right? Pardon, sorry? The future, yes, okay, that's good. How about you at the back, my man? Okay, that's good. All right, yes. Information, digital information, okay, yes. Problem solving, yes, very important as well. So yes, great answers. So you lot basically know what the answer is, but just to give you an example of what the standard definition is and what our definition is. So obviously I've taken the one on the left from Wikipedia. So technology is the sum, techniques, methods, and processes used in production of goods and services to accomplish an objective for scientific investigation. Quite a mouthful, right? So for me, if I'm trying to explain something to people who are just starting out in technology, I'll probably move to how we've SkillStruct simplified it. So onto this side, for me, I just put it's a concept where using hardware and software to move data in order to help human development. So a lot of problem solving there. For example, quick, easy one. How many people use their phone as an alarm? Raise of hands. Most people, right? Okay, most people do that. So that's an example of technology, right? We depend on technology to problem solve, as we discussed in the back, innovation as well. There's been so many great things that we've been able to leverage with technology as well. We've got smartphones now. Before, I guess there were dumb phones. So we've transitioned now to smartphones. There's so many things, so many examples of technology in this room. People can only watch us virtually because of virtual technology, right? We're streaming this right now and people have access to this. So if they're in a different country or for a reason they can't make it, because of technology, the innovation of technology, we're able to, solve an issue really, which is how can I see this? Hopefully people feel it's a great talk, live and in person. Virtual technology is an example of that. So that is exactly what technology is. So think about data, think about moving information, think about, problem solving ultimately is what technology is. And then we move on to what do we think the future, as someone was talking about there, of technology is. So we have a similar thing. So what is the future of technology? What are some of those examples? What are some of those things you're hearing that is the future of technology? Or even now of technology? Machine learning, okay. Yeah.
I think technology is going to become more
sustainable. Okay, sustainable tech, that is a thing actually. Anyone on my left?
So what we saw a couple of years ago in fantasy movies are going to become reality.
Okay. What movies?
I don't know, probably.
Oh, okay. I mean, I hope not. Well, at least many, many decades from now when I'm not here. But yeah. Terminator. Oh gosh, you're picking the movies, aren't you? Okay. Any positive movies? Any positive? Okay. Okay, fair enough. I'll move swiftly on from that one. Any other examples of, is automated? That is very true, very important. So you see, you've got self-scanners, for example, right? A lot of that has been automated now. Before, there used to be only people at the tills, and now we've transitioned now where you don't need any assistance from people at the shop. You can easily just go there. Who's seen those Amazon shops where you don't even need to do anything? You just walk in, pick your stuff up, and just walk out. All because it's tied to your account, and through sensors, things like that, it's able to just basically track your account details and do all the calculations like that way. So we are moving, we're already there pretty much with some of these great innovations. So I'm going to. Yeah. Yeah, but no one's telling you to go in there though. So it comes with its, great perks, but that's some of the things that's right. Fortunately, I do a talk on that, but we don't have time for this one. That is the consequences of technology, good or evil. That's an interesting debate that we don't have time for, but yeah, you're right, for sure. But these are some of the things that for me, I think is very important when we are talking about technology, is cloud technology. So obviously in the quiz, you learned that, it's one of the highest paying domains, but I'm just curious to know who knows what cloud is. Could someone explain what the cloud is? I know you know. Yes. Okay, that's a good example.
Making a lot of computers work together for a common goal.
Okay, yeah.
Someone's computer, but a lot of computers.
Yeah. Does anyone else? Do you want to say something?
Using servers from someone else's, and then software as a service. It's actually really the cloud is basically running services.
Yes. I think they call it the cloud because it's wireless and you use the internet ultimately to connect. An analogy I like to use is, Spotify and things like that. You don't own the physical music, for example, but you pay a subscription, as you were saying at the front, to stream that over the internet. That's an example of cloud technology at work. See, Spotify might use something like Azure or AWS to host the physical music, for example, and we use the internet to access that. So that's an example of the cloud. And there's lots of opportunities with digital transformation when it comes to cloud, infrastructure projects, or, we call it, well, in my previous organization, Journey to Cloud, where essentially what you do is you get legacy systems from companies and ultimately bring them up to, 365 or Azure or whatever really. And that's, again, a lucrative market because, cloud technology is here to stay. Got another one, which is AI, machine learning, that was also said as well. So when we talk about artificial intelligence, we've got things like Echo Docs, things like that. Who has, an example of that, like Echo Docs or, the Google equivalent? Yeah. How many people actually have those? I'm just curious. Okay, so we've got a few people that have that. So actually, that's an example of artificial intelligence, right? It's meant to be simulating human behavior. You're able to give it instructions, very basic ones, but it's able to respond to you, perhaps have a limited conversation. So that's an example of technology. And this is an example of innovation. We're still very much in that scale when it comes to innovation within AI and machine learning. And so for someone that is interested in those sort of technologies, that is definitely something I'd recommend in terms of a potential sector. A lot of the languages used are Python and things like that. So if people are interested in Python and interested in machine learning, that is definitely an example of where you can actually go with AI. Sorry, do you have a question?
We are using every single day Google.com. It's self-presenting because even before we think what we want to search, it's coming up with that.
Exactly, predictive text. And that, is an example, and actually leads on to one of my other examples as well of data science. So who's interested in data science? I'm just curious. Let's raise our hands. Oh, wow, okay. We've got a few people interested in data science in the house. Okay. Is that because of the maths question? I didn't know if there was 12 hands, but I did see there was 12 people that like maths. So maybe there's a relation there. I don't know, but that's cool. But yeah, so data science is, again, very important. And it's one of those like very hot, opportunities right now, because with data science, there's a lot of, information. And like I say, technology, the fundamentals of it, it's all about moving information and manipulating information and displaying information and acting on information. And so for, data scientists in the room who want to be data scientists, very important to understand there is a place in there. And maths, obviously, making predictions, predictive, text based on information is very key. A lot of people ask, where do I start and how do I get into data science? Again, having the maths is there, that's fundamental. But then using languages like Scala, for example, Python, again, very instrumental in terms of working with data science. And so, again, the great thing about data science for those who might not like coding, because there's a few people who said that, is you can really just focus on the mathematical side of things. So data science is definitely an industry to think about because it's here to stay. And it's one of those languages that's definitely, or concepts, I should say, worth getting into. Cybersecurity. Okay, so who's the guy on the left? Okay, there you go. So for those who put Alan Turing earlier, this is the real Alan Turing. And so this guy, do you know why he was important? Yes? Oh, sorry, what were you saying? Yes, yeah, brain code. So yes, generally, so this person during the Second World War helped the British, decipher German text, and because of that, ultimately that helped led, our victory. So very instrumental. So there's a very famous place called Bletchley Park in Milton Keynes. If you've heard of it, I definitely recommend it. I've been there a couple of times with some students. Definitely worth exploring. But this guy, because of him, a lot of the innovation that's happened in the cyber world has all come from some of the knowledge that he's bestowed on us. And so, cybersecurity, when we're talking about cybersecurity, who's interested in cybersecurity? Okay, so we've got a few, not as much data science, but that's cool. And so data science, cybersecurity, sorry, is very, it's a very pivotal, thing. If you like hacking, good hacking, I should say. Has anyone heard of the concept of ethical hacking? Okay, yeah, okay. Do you want to explain what ethical hacking is?
It's like hacking for ethical reasons when some company might ask you to check if their system is safe.
Okay, yes, so similar to what it says, so you hack for moral reasons. And again, there's a debate in itself whether there is such a thing of, ethical reasons. When there's wars, for example, that's often used a lot. We hack this server because it's in the, country's interest, but whose country, right? So it's a very interesting concept, more from a philosophical point, but also from a programming standpoint as well. So a lot of things that relate to cybersecurity is concepts like encryption, decryption. So for example, if you have that word cybersecurity, if you put a algorithm like a Shah algorithm, for example, that can look like random text, and then use a very interesting algorithm to convert that back into normal cipher text. So that's an example of cybersecurity, and talking about the likes of hacking, very important concepts when you do get into it. And digital forensics, all of these sort of things are very pivotal into that. And so if you are interested in, solving things, and again, maybe you're not the most, technical person, there's things like digital forensics that can also get you started as well. Okay, and then finally, for those who are, maybe not, tech savvy or don't like coding and whatnot, it's very important for me to stress as well, there are people that are needed within the technology industry who aren't so technical. So project management, for example, we discussed Agile in the quiz. Who knows what Agile is, by the way? Very important if you want to get into the tech industry. Okay, so a framework for project management, kind of, yeah, kind of. So was there another hand on? Yeah, definitely elements of that. So I guess Agile is ultimately a way of life, really. It's more philosophical as opposed to technical. And basically, based on that theory, we've built a lot of frameworks around it. So like Scrum is a popular framework based on Agile ethos. So, smaller chunks, iterations, sprints, where you do create code or create things within a 2-week period. And so for those who are interested in, being a part of a team, as a software developer, Agile is definitely something that you're going to hear again and again, because a lot of what you'll be coding and a lot of what you'll be building on is, based on Agile methodologies. And again, very important to understand that because, actually, that's a good question. Who is interested more to be a project manager as opposed to someone technical? Or do we have all techies in the room? Okay, that's cool. That's cool. Oh, couple unsure. Okay, at the front. That's okay. That's good. So this slide is more for people, and there might be people online, for example, just to get an understanding. Maybe you feel a little bit of imposter syndrome, for example, feeling that you don't belong in the room because you don't have a passion for coding or whatnot, or you feel like, is there any chance of me to get into it? Can I learn coding? Maybe you feel like you have to learn coding. I'm also here to also say I've had roles which were non-technical in the industry, and they are needed. I worked for a large consultancy firm before, and not everyone there is technical. So I think it's very important to understand that just because you're in the tech industry doesn't mean that you're necessarily a coder or anything like that. You can be a project manager, you can be a tester, for example. So there's loads of avenues that you can get into. Okay, so some of the pathways. I'm assuming not everybody has, maybe a job or whatnot here. So these are some of the pathways that I've discovered, through my own journey and also through my network as well, how I've helped people in the past. So there's the traditional ways. Obviously, I talked about, going into university and, getting a job that way. So, 9 out of 10, that's how most people get into the industry. There's also internship opportunities as well. So, applying for apprenticeships, for example, that's becoming more prevalent now as I'm working with organizations. That's become more of a thing where people, I'll say you don't have to go to uni, we'll train you up. You just have to have an interest in technology and we'll do the rest ultimately. So it's that way. There's also volunteering. And so for those people who are thinking, oh, how do I get into the industry? This is often an underrated way of getting in, just by offering your free time to work with organizations, to build up on your skill set as well, right? A lot of people say they really want to get into the tech industry, but, how do you just show that, right? We'll talk about that more in my next segment, but very important to understand, you need to think outside the box when you're thinking about, volunteering and things like that. There's good opportunities to get into the tech industry that way. And then there's mentoring. And I'll talk about mentoring soon because we have, something really interesting happening with our organization when it does come to mentoring. But mentoring is also a great way. How many people in this room have been mentored before? Wow, you see? 2 people. Honestly, sometimes it's, none. Sometimes 1 or 2. It hasn't gone past 3 yet since I've been doing this. But it's really amazing to me, actually, how, a lot of people who want to get into the industry haven't got that sense of mentoring, right? And so people, again, mentoring is also a great way. I've seen people reach out to people on LinkedIn, for example, about mentoring, or, when you're networking, oh, what do you do? I'm a senior person at this, or even a junior person at an organization, you can get mentoring from them as well. Right, we all start somewhere, right? And so this is another way you can potentially get in. And I know there's lots of initiatives when it comes to mentoring as well. We do it, so we know when it comes to these opportunities, they do exist. And this could be another way of getting into the tech industry, or at least understanding if you actually want to be in the tech industry. A lot of people romanticize the technology industry because, innovation is very slick and things like that. So it's very important to understand that, and maybe mentoring could give you that insight as well. Okay, cool. So the next segment, I'm just talking about, our practical framework. So we talked about Scrum, we talked about, Agile, this is our philosophy when it comes to, getting into the technology sector, or you can use it to just, want to obtain success. This is often something that we run when it comes to, I want to be productive at this. How do I get about that? So first thing I always tell people, and let's say you want to get a job in the tech industry, the first question I'm going to ask you is, have you done any research, for example? Let's say you want to be a data science developer. So, do you know the languages, the top languages when it comes to data science, right? Do you know what organizations do, data science and things like that? So start doing the research first. That's normally the first stage when it comes to looking at how do I get to that next stage of ultimately becoming a data science developer. So research is the first stage. And then we've got things like investment, right? And so investment is very key. I don't necessarily mean money. I just mean the time taken. So a lot of people say you want to do this, you want to do that. But then I'll ask a young person in my network, for example, have you invested your time, for example, in that? Have you allocated a slot where you're going to be consistent and, study, or, try and do some, I don't know, data science tutorials and things like that? And even if I'm not talking about money, I think an interesting thing about money is, if I ask most people in the room if they have a Netflix account or an Amazon Prime account, put your hands up if you do. Just show of hands. Amazon Prime or any of those subscriptions that you pay as a service. Most people tend to put their hand up, But when I talk about things perhaps like Pluralsight or an Udemy course or LinkedIn Learning, most people put their hands down. And I always find that very interesting, right? Because we're thinking about our career, we're thinking about how to, get into the tech industry or whatever, right? A lot of people will prioritize one thing instead of another thing, especially if that's more lucrative to them. Just a quick anecdote from myself, in my first job as a software developer at Office of National Statistics, I paid for a course on Pluralsight to learn about C# development. And because of that, I had an interview in a couple of weeks. And all I used in terms of my learning was based on what I learned in that tutorial, which cost me $10.99. I was able to earn 15,000 more because they offered me the job. And, that 15,000 versus, I don't know, subscription can help me pay for years of subscriptions, right? So it's all about perspective, right? And so how you invest in your time, more importantly, but equally, if you wanted to money as well and prioritize it. You say you want something, but how badly do you want something, right? And so for me, I always knew I wanted to get into the tech industry. And so I was really driven to do so by, doing by any means necessary for me. Can you honestly say that's the same thing? And some of you, it's a yes, some of you it's a maybe, and some of you is maybe a no as well. So that's something to often reflect on as well. So then we've got structure. Structure is very important to me. It's half of our organization, of our ethos. So what I mean by that is, being able to be consistent with your time. So if you have, let's say you're available today to come to this talk because you put in your timetable, for example, maybe tomorrow morning you have a lecture, or you have something else. So it's not a good time to put some studying in or some investment or some research in, right? So when we're talking about, applying that theory practice and actually being consistent, I want to be a data science developer, are you actually putting in the hours? Very important to have a structured timetable or routine. And then finally, evaluation. And so evaluation, what I mean by that is, being able to give feedback, for example. So, random example, how many people have applied for a job and got rejected before? Okay, most people, all people, I would say. So very important, but how many people get feedback somehow, during that process, right? How many people ask for feedback? How many people, are able to take that and then move forward? Maybe a couple of you perhaps, but not most of you, right? Einstein said insanity is doing the same thing with different results. And so, for example, right, if you're never progressing, you have to ask yourself, what is it that I'm doing, wrong or something I need to improve on? You'll be surprised how just simple feedback you're able to get. Maybe you're not able to get it from the company, but you should be able to get it from your peers as well. So if you two, I'm assuming you came together. Did you two come together? Yes, okay, cool. So if you have an interview, for example, maybe she can help you and give you some tips and tricks and stuff like that and give you feedback because you just never know, right? So very important to always, get evaluation from one another. And so when you put that all together, you've got the evaluation, structure, investment, research, that comes down to a very nice acronym, I would say, called the RISE methodology. And so this is our methodology that, in theory, if you put all of this together, you should rise, hence the, analogy, and be able to achieve, whatever your goal is, whether it's being a data scientist, whether it's you like maths and you want to do data science, or if, you like Python and you want to be a Python developer, whatever it is, being able to apply the RISE methodology should help you on your journey. Okay, so moving forward. So just to round off a little bit, so obviously moving forward from this talk, you can either go, a couple ways. Go to the future of how you can learn from this, stay in the past, or stay, standing where you're not moving forward or backwards, you're just stagnating, which to me means you're still living in the past. So moving forward, just to talk about my organization a bit, I want to leave it to the end. So what we are is a technology and early careers consultancy. We work with organizations on workshops, recruitment, talks, strategy and things like that. And we also work with young people or people looking to get started in the industry with our network, SkillStruct University. And so just to explain, SkillStruct University is predominantly virtual. And so what we do as an organization is we run different workshops and things like that. It's a platform to help people on their career and personal development. I should stress as well, being a part of the network doesn't necessarily mean, oh, you get a job. It has gotten people jobs before in the past. But what we more focus on is the personal and the career development as well. So different people have taken different things. Some people want to get into blog and writing articles. So we've helped and support that, for example. Some people want opportunities to just build on their skills. They're not sure if they want to get in the tech industry, so we help them out as well. And some people just, want mentoring, and we also help with that as well for young people. And so, how we ultimately work as an organization when it comes to awareness is creating content to educate. So we have a series of different things that we have created in the past 6 months. So Tech Job of the Week, where we explain certain job opportunities, so like machine learning, or we review CVs. So for example, how many people in this room can confidently say they have a great CV? A great CV? Absolutely. Huh? If it's not great, what do you want me to do? Huh? That's going to be a tough one. I ain't going to guarantee that, but you sure? Okay, cool. We'll talk after. I'm not giving you a job or anything. I'm not guaranteeing it, but give some feedback. But yes, okay. So for example, apart from that one person in the room, no one put their hand up, right? So it's important to, all these things, you want to get a job, et cetera, but without a good CV, it's very hard and difficult. So what we've done with our network is we've reviewed some of our member CV and given feedback. So again, an example of how we educate, and we know it works because the next infographic next to it is, someone from our network who used it to become a web developer. We've got things on digital governance, study hacks, and tech talks as well. So yes. Yeah.
Every single time this question is going on here, I would say my next revision will be the greatest.
Yeah, of course, and that's true. Like that's why I don't actually think there's a concept like the perfect CV. So that's why I expect most people, all people, to put down now. Even my own CV could be revised over time, right? It's just as I get a new job or new things, we all can review. But there is a base, I should say, an algorithm behind most CV checkers that you have to have fundamental things on your CV in order to pass that algorithm. Because when you do apply for jobs, you might not know it, but there is an algorithm assessing some key indicators in order to move on to the next step. Okay, cool. All right, so, because of O'Reilly, I've mentioned it before, we're also an organization partnered with great organizations like O'Reilly, like Microsoft as well. That gives us opportunities to do things for people on our network. We also, again, we're here now today, so that's proof. We do a lot of talks with Microsoft, the Reactor. We do a lot of things with employees of Microsoft as well. So I'm going to Leicester University to give a keynote as well pretty soon. And I'm going to be taking a couple of people from Microsoft, for example. So we have a great relationship with Microsoft. We have a mentoring program on our network as well. We do have a video coming out in the next week or two about, pairing 2 people from an organization, and now this person on the, I think, my right, so I'm guessing your rights as well, is gone to Nike as a placement student in Amsterdam based on, mentoring, but also another number of factors, right? So it does work, the power of mentoring. It's a really good opportunity as well. And also, just if you want to keep in touch as well, here's a QR code. I will, if people come up to me and want to talk more about some of the stuff I'm whizzing through, you're happy to do so. Feel free to take a picture of that. I'll give you a second to do so. Okay, I'm gonna move on. Cool. All right. So, for all that, if you are interested in joining our network, depending on if you can, all we ask of you is supporting our content, being a champion to other organizations and people about us, introducing us, and really help amplify the platform. SkillStruct University itself, at the moment, is a free platform for young people and people starting out. However, that might not always be the case. And part of the reason that we really ask people to support what we do with that is because we want to keep it a free network. So that's what we ask of you. And so some of the roundups, takeaways is, hopefully now you've got more of a sense of what the technology industry is through my journey and through some of the examples that I've given you and through the quiz as well. Any feedback you want to give, feel free to have a conversation with me afterwards. And I guess the next steps is ultimately up to you, because you lot are relatively new in your career paths. You've got the currency of time at the moment, so use it. I can't get that time back from when I was, 20 years old or whatnot, or starting out. You have the opportunities to make mistakes, and so I guarantee if you make those now, it'll definitely help you later on in the future. And just to say thank you for taking the time as well, taking time out. I enjoy these as much as people enjoy watching me and listening to my conversations as well, and it helps me improve all the time as I give these talks as well. Any questions? Okay. Oh, one question. Scala language. It's a language called Scala. It's S-C-A-L-A. Scala. Yeah. So, any other? No? Okay. Thank
I just
you.
want to say a massive thank you, Michael. That was a brilliant quiz and fantastic.
Thank you very much. Thank you.
I'm going to say, save any questions for the break, because we've overrun slightly, but that's fine. It's totally cool. Yeah, absolutely amazing. It's brilliant to see you break that down in so many different silos, especially mentoring. Mentoring is imperative and absolutely massively important part of technology. I mean, I wouldn't be where I am today at Microsoft if it wasn't for my mentor. So thanks for bringing that one up. And also mentioning imposter syndrome. It's a huge thing. People don't realize. So with that in mind, if you have any more questions, please do ask at the break. But we're going to break now. There's Taco Bell food up there, so go grab some. And then for the online audience, we're going to have a video playing, which is GitHub, or how to deploy a CV to GitHub. And of course, if you're in here, you can also watch that. We'll make sure the volume's turned down so you can actually talk to one another. And then we're going to be back, and we're going to have Darshna and Richard, and they're going to be talking about AI.
Ooh,
so
okay.
Go and enjoy your break, and come back at about 8 o'clock, so 25 minutes time, and we'll call you back.
Awesome. Cool.
Hello everybody, I hope you are enjoying the in-person session. Of course you're watching online, but I hope you're still having a good time. Now, this is the half an hour or 30-minute break that we usually have in the middle of our meetups here at the Microsoft Reactor. But instead of just leaving you with a blank screen and leaving you with nothing to do, I'm going to take you on a little journey. I'm going to show you how to deploy a portfolio, so a CV, to GitHub Pages. This is all free. And we're going to show you how to do that online over the next couple of minutes. So, what is GitHub Pages and why is this so good? So GitHub Pages is a way for you to deploy a website with a pretty okay URL, which you can share around for free, so you don't have to buy one. And you're able to deploy it straight from GitHub itself. Now, today I'm going to just be using github.dev, and I'm going to create Homer Simpson's CV. Of course, you can take this using your own template or using your own information, and you can take this away and deploy it yourself at home. So let's get started, shall we? So you can see on my screen, I have come to my GitHub profile, and all I'm going to do from here is create a new repository. So I'll go to repositories, I'll click on new, I'll give it a name. So let's just say Homer Simpson's digital CV. And I'm going to give the owner myself, because I'm part of many orgs. And this is just going to be a digital CV for Homer Simpson to share with the community. So if you are applying for jobs, if you are wanting to show people what you're currently working on or different skill sets that you have, this is a perfect way to do it. I'm going to make it a public repository, as it needs to be a GitHub Pages profile. I'm going to add a README, and that just tells people what is actually in the repository when you are creating it. I'm not going to add a git ignore because I'm not really using any language. I mean, I'm using HTML and CSS, but let's just say if we have one in there for HTML, we don't really have one for HTML. There may be one for CSS. This is just a good way to prevent files that you don't want in GitHub being pushed to GitHub. I'm not going to give it a license. I'm not too worried about having a license for now. Of course, do your own research when it comes to licensing. It's just how the code is used outside of your public repository, whether people can monetize it, whether people can use it in production, and so forth. So from now, I'm going to create the new repository, and that's just going to create this in GitHub for me. It's going to be empty. Now, this is really interesting because usually you would clone this, so you'd go to code and you would either use the SSH, HTTPS, or the GitHub CLI to clone this repository to your local system and then edit it in a code editor on your own computer. However, I am going to be opening this with github.dev. Now, to do that, I'm just going to be inside this repository, and all I need to do is press the full stop button on my keyboard. And it will open up an online editor for me. Now, this online editor is github.dev, not to be confused with vscode.dev. vscode.dev is purely just a VS Code editor inside a web browser. This is much more tightly coupled with GitHub, allowing me to do pull requests, add code changes, and make commits, and so forth. So what am I going to do in here? Well, I need to create a new file. I need to create a index.html file. So let's go ahead and do that, shall we? So index.html file. Cool. What do I need to put in this file, you ask? Well, I'm going to copy across a little bit of code because it's a little bit quicker than typing all of this out. But essentially, all I'm going to do is drop in the body or the template, of which you can get yourself for free. This one I actually got from W3 schools themselves. This is just a CV template. Now this looks like a lot of code. Don't be scared. All this code is telling the browser it's a doc type of HTML, so to expect HTML code. The language is English, hence lang equals en. We are going to give it a bunch of metadata in the heading, so some style sheets, references. I'm going to give it a title. I'm going to give it a couple of font families for the different headings that I have, and then I'm going to break down the different containers. So I've got a grid, I've got a left column, I've got what else have I got? I've got another container which is going to have the different bits of information of Homer Simpson himself. Going to have some skills, so leadership skills, eating because Homer Simpson likes to eat donuts. We've got music that is into physical prowess, and a whole bunch of other information on this CV. But you say, Liam, that looks rather boring. How do I know what's really going on? So let me just save that for a second. And I don't need to add any CSS into this because I'm using the style sheet references from W3 schools. I'm using Google APIs and Cloudflare. So those are my style sheets that I'm pulling from, which of course can just be links. And of course the font family, sorry, the Google APIs one is font family of Roboto. Interesting, right? So let me go ahead and install a plugin which will help me visualize this. Because if I was to go ahead and just deploy this, and I want to see what it looks like every time, I'd have to keep deploying it, adding code, pushing it to the repository, deploying it, having a look, and going around in a round robin cycle. Okay, that's not very fun, and it's very laborious, very annoying, and there's a way to make that a lot easier. So let's go to the marketplace, shall we? And as you can see, I'm going to search for CodeSwing, which I think is already there and is actually already installed. So let me just go and install it, and let me just reload this. So I actually want this to be uninstalled. I just need to go ahead and install it again, but I want to do this, show it from your perspective. So if you were to go and have a look in the marketplace, now being in github.dev, you don't have all of the marketplace plugins that you would as if it was your local machine, for obvious reasons, but there's still a fair number of them that you can install. So let's go ahead and click on CodeSwing, shall we? What is CodeSwing? Now, CodeSwing allows you to see your changes to a HTML file or a JavaScript file or something going on locally, in github.dev, and it allows you to see the changes in real time. So as you can see here from this little GIF that's going on, you can see that it's changing some of the HTML, and you can automatically see the changes happening straight away. So let's go ahead and install this, shall we? And hopefully, if we go back to here, what we need to do now is go and create a CodeSwing project. So now I've got CodeSwing installed. Let's go ahead and create that project that I was just mentioning. So let's open up the command palette inside github.dev. Now to do that, you need to do Command, Shift, and P if you're on a Mac. I'm not sure what it is on Windows, but that is what I use. So let's type in CodeSwing and let's initialize the workspace as a swing. And I've only got HTML only. I could have CSS, JavaScript, TypeScript, and whatnot. And of course, there are a whole bunch of others. So React Native, just JavaScript, HTML, and CSS is what I think it really supports at the moment. Let's just go HTML only because I don't have anything else in this. It's just a pure HTML site. Straight away, you can see that it has wiped my index.html. That's not what I was expecting, but don't worry, we can just go and pop that straight back in. I didn't save, I didn't commit it, that is my fault. So let's go ahead and put that all back in, shall we? Let's go and copy that and paste it in again. Now straight away you can see that that code straight away updated on the right hand side, except for one thing. The avatar picture. I don't have a picture, so as you can see, Let me save that one. Let me go and pull in a picture from my system. So let me go and grab a download, shall we? It's going to be my downloads, Homer Simpson JPEG. So let me just go and find that one. Let me just go and pull that one across and pop it into here like so. Now let me rename that one because it's got a number 1. I've clearly done this before. Like so. It's been renamed. Let me close that one. Now hopefully if I save the file, straight away you can see on the right hand side I now have a picture of Homer Simpson up here. Now this is a wonderful CV. I could go ahead and change all the different things inside it. I could then go and see it update on the right hand side. And likewise, it's just a template, so you can take this away yourself and work with it. But what I'm going to do at this point is I want to push my changes to GitHub. So let me go to the GitHub plugin. And as you can see, I've got a couple of changes. I've got a few files. Now let's just go and give it a message. Let's say create Homer's CV. Okay. And I'm going to click that tick, and that tick is going to upload these files. It's going to push it. So it's going to commit and push the changes to GitHub. So from here, I can then go to GitHub, and let's go and see those files in the repository. So if I click on, go to the profile, click repositories, Homer Simpson's digital CV, and I can now see the files are there. Wonderful. So now since we have created a CV, we have done the coding, we have created the files, they're in GitHub. What next? Well, we now need to actually deploy this. Now the way to deploy this is with GitHub Pages, of which I will show you how to do. So let's go and have a look at the repository in GitHub itself. So if we navigate to the second tab that I have, this is the repository, like I've showed you before. We've got a codeswing.json file, we've got the Homer Simpson JPEG picture, we've got the index.html file, which is essentially just the code that creates the website for us, and we've got the README, which is this front page we are seeing here, readme.md as a markdown file. How do we deploy this into a viewable, public viewable website portfolio? Now, of course, this doesn't need to be used for just a CV. You could use this for a photography portfolio, your languages portfolio, a travel blog, anything that you really want to, okay? There's a number of ways you can do this, and we'll talk about pictures shortly and how to use them, or the best ways to use them when it comes to hosting digital media like this. So let's go to the settings of the repository. Now, of course, being your repository, you will have total access to this, administration control. And this is why I said it needs to be a public repository at this point. Because if you go to Pages, if it's not public, you will get a big error saying you can't create a GitHub Pages with a private repository. So what we're going to do is select a deploy branch, which will be the main branch at this point. It's going to be down here, it's going to be main. And of course, if we look at the source, you could grab it from GitHub Actions, but we're not going to because that's in beta. We're just going to keep it as root because we don't have any other root directory. This is just a pure root of the whole folder itself. And we're going to click Save. That is all you have to do to create a GitHub Pages repository. Now, what is that going to do? That is going to create an action in our repository called a workflow, so GitHub action, okay? And then it's going to give us a URL that we can click on. So if I go to Actions, we should see one right away. So it's called Pages, Build, and Deployment. So let's go and have a little look at this and see what's really going on. So you can see the first stage is to build everything. So it's going to compile everything, all of our code up into a package, and then it's going to give a status. And if it's okay, then it's going to go on and deploy. If it's not okay, if there's any errors, then it will tell us that there's some errors. So let's dig into build. Let's go and have a look what's going on. So now it's checking out the code. It's going through, it's building it with Jekyll, which is just a build engine that GitHub Pages uses. And you can see it's already created it. That was super quick, that was. But now we can go and have a look at the status, and it'll say, hurrah, it was all good. And it's going to do the deployment stage for us next. So let's go back and have a little look at our Pages page, shall we? And of course, here we go. We can see it's updated. and it is saying your site is live at the repository, so my username .github.io/the repository name. So I forgot to mention earlier when creating this, the repository name does affect the URL that it is deployed to. So I should hope by now that it deployed, because I left it a moment ago on the deploy stage. So we can click on visit site, and straight away we have got a publicly viewable CV for Homer Simpson. Now of course, this is just a template. There's really not much on there. And if I really wanted to create one, I could go to town with CSS, I could go to town with HTML, make it look beautiful. But this was just a free template that I took from W3 Schools, which hopefully if you're ever learning web dev or if you're interested in learning any coding, it's probably a website that you're familiar with, if you've ever come across it. Now from here, I mentioned how to work with images, because if you didn't want to create a CV and you wanted to create a portfolio, how would you store images? Well, two ways. I personally choose Imager, which is a really good way to cloud host images. It's just a platform, it's free online. Or you can use Azure. So if you have an Azure account, you can store them in Azure Storage, and then you can just reference them. You can reference them with a URL, and then you can just pop that into your Markdown, your HTML, and ta-da, you'll have images that are pulled from the cloud, so that it's not so reliant upon GitHub pages themselves, because that could create latency. It could be quite slow if you have lots of images. But that's how I would do it. Now, go ahead, take this away, and I'd love to see what you create. Please do, give us a follow, and ping me on Twitter, or TikTok, or wherever, and let me know what you create and how you get on with it. And if you have any questions, please do feel free to reach out. But for now, I've got to get back to the in-person event, and I hope you enjoy the rest of it. Thank you very much. Is for workflows, and AI is for innovation. And this is going to be by Darshna and Richard. So it's great to have you here, and I'm going to let you take it away.
Amazing, thanks. So we struggled a little bit trying to think of this title. We'll introduce ourselves in a second, but one of the things that we were asked to do was to talk a little bit about why you should all do AI, how you should be thinking and feeling about AI as you sort of graduate and move into your careers. And I thought, because I'm a software engineer, I've been a software engineer since 1996. Darshna is a data scientist. And I thought, how can I make software engineering sound really, really boring? So I thought we'd start with half of our title. Engineering is for workflows, because it's kind of very, very predictable. Rinse and repeat in the way that you would be thinking about it. Software engineering is very, very complicated, but we chose the title like this because it actually shows the value proposition now between software and data science. And if you look at startups across the world, if you look at where businesses are chasing, and they're saying that data is the new oil, it's because their entire focus point is on AI. So we wanted to differentiate that in our core message, just to say that there are some problems which are still complicated, but they're solved, and you don't have to work as hard, and they're not the ones that are bringing the value. The ones that are bringing the value are the ones that you see there in the latter, AI. Just to introduce myself, I'm Richard Conway. I'm one of the founders of a cloud and data consultancy, ElastiCloud, with several international offices now, and a real zest to move more from that into that engineering space, into product development. And AI. And for my sins, I'm also a former Microsoft MVP in Azure. So I've been using the cloud since its inception, and a Microsoft regional director as well, which is a fancy title. Actually, I'm not quite sure.
Question. What does MVP mean?
Most valuable.
Sorry.
Yeah.
There you
I
go.
think I was conditioned to say most valuable primate, but it is actually most valuable professional. It's a retrospective award for people that do community activity. And so if you have a user group, if you're very active with blogging or open source, or you really put it out there with Microsoft technologies, then they'll reward you 12 months later with a title like that.
Hi everyone, I'm Darshna. So I am the Director of Innovation at ElasticCloud. Particularly, I head up building AI products and sustainability. Prior to that, my experience is in academia, so I have a PhD in neuroscience that I focused on looking at mechanisms of epilepsy. And I've been with ElasticCloud for probably about the last 6.5 years, initially starting on the consultancy side of the business, working across many different industries like aviation, energy, health, education, etc. But since probably about 2018, I've been focused purely on sustainability, focusing initially on renewables and more recently within ESG and supply chain analytics. I'm also a Microsoft AI MVP as well.
Okay, so we've got an agenda today. I think we've got quite a few slides, so we're probably going to totally blow our time budget. So I'm going to say this up front because we're very chatty. So we wanted to focus on some of the differences between engineering and AI. You've heard some good boilerplate definitions tonight, and really think back to what the mathematical origins of AI are. I'm old enough to remember the artificial intelligence book that I had on my course, which was I think it was a red Prentice Hall book, and in this book, at the time there was Marvin Minsky's MIT lab, and everybody was going crazy over the difference between strong and weak AI, and will these new generation of bots pass the Turing test next? And it's not even anything we discuss anymore. It's just like I feel like this entire history that I had to endure, right, of all of these people, which got up to this creative point at around about 2015, 2016, when neural nets started becoming useful, right? In my career, I almost had these 2 silent decades of nobody discussing anything, of like where this revolution just didn't happen, and now all of these things are just commonplace for us. So you guys don't know how lucky you are. You don't have to endure 2 decades of this. So we're going to talk quite a lot around some of the things and the drivers for AI, which Darsh is going to introduce. And we're going to talk a little bit about how we think about skills and how we develop skills internally and externally for our customers. Okay, so so I'm gonna throw this out because these are all problems that in my heyday I was asked to solve, and some of them have even got fancy names like traveling salesman. When I want people to put their hands up, so otherwise I'm just going to pick someone at random. Let's look at the top one. How would you approach a problem like that? Right, you have a network of roads, and you need to find the fastest route between 2 roads in the same city. Yeah. Well, I'll give you a clue of where I would start.
I remember this is more like problem solving, like trying to look at the first step would be to look at the different scenarios involving taking each of those. This route might actually seem shorter, and then there might be some obstacles on the way. So it's more like problem solving, and it's one aspect of it. Do I have a helicopter?
You have a magic wand. You can do whatever you want.
Take the straight right.
Okay. So let me give you a clue. How does the internet solve this problem?
Based on the user feedback,
Making search.
Just checking the location of every post, and just people analyze what is the process.
Yeah. So the internet has a protocol, OSPF, and what it does is it approximates the distance, it works out some statistics within this protocol, it understands what ping times are between routers, and then it works out what the fastest route is between this. So it collects a lot of information. The thing about a lot of these is that the computer scientists will divide these into different problems that you can solve in different time. And they'll talk about polynomial time, non-polynomial time, NP complete problems, and you have this entire mathematical framework across these. But do you know how people solve them today? Exactly. They don't solve them because they've already all been solved. Okay, and this is my point. There are some clever things that you can do. You take a look at the bottom one. What's the fastest way to calculate the first 100 prime numbers?
Already someone would have calculated.
Well, there is, but you would need to know theory, right? Well, what is a prime number? I teach 5-year-olds, right, and they're quicker. Come on, guys, come. Need to be sharp. Yeah. So if you were writing an algorithm to create and you were in competition with somebody else to do this faster, how would you write that? What things might you want to know up front?
Already solved. So caching, something related to caching.
So I mean, well, the first thing is that any even number can't be a prime number. So you exclude all of those from your number space. But then you might drill into some theory. You have additional theories like prime twins. So if you knew that, what you might know is like the proximity of certain numbers. 13, yeah, there you go. The proximity of certain numbers within the initial number space, right? If you understood that theory, right, you could automatically exclude or you could test twins in different ways, right? And that would speed up your algorithm. But somebody's already done that. You know, somebody's already done a lot of that work in primes because primes are the backbone of internet cryptography, right? So we need software libraries to do these things. So the point of this slide is to say that the last 25 years of my career up to now, right, were all about trying to initially solve some of these. They're already solved. Don't bother with them, right? Learn about them, learn how they were solved, but you'll never need to know how to solve them in your career. So I'm going to hand over to Darsh just to tell you about all of the things that should get solved. Have I shown you this slide yet?
I don't know.
I put some nice pictures in it as well, just so.
Okay, exactly. So this slide is talking about different use cases that we can use machine learning for. So you've probably seen a few of these examples in previous talks given today, but we have image recognition. So being able to recognize a mountain from a set of photos. If we have enough training data, a big enough training data set of various different images of mountains, amongst other things, we can train a model to understand what are the features that define a mountain. It has point, it might have some other distinct features that vary in scale relative to the mountain, etc. Detect someone who is trying to use your credit card. So a lot of financial companies have a lot of these models in place already. When we're using our mobile phones, you enable location so that they can keep track of, okay, well, your mobile is currently in this place, but apparently your credit card has done a transaction in another place. So they're the type of features that would go into a machine learning model to kind of detect if your card is being used fraudulently. Medical image for cancer. So this is an interesting one, and I'll get onto this in a little bit later, where AI is really applicable versus not. We have a lot of kind of medical professionals that have spent a lot of years kind of developing their skills to understand what is an image of a cancerous X-ray, etc., versus what is not. And with enough training data, again, we can build that into a machine learning model. Work out what someone is saying with a Scottish accent. I don't know about the Scottish accent. I think I'd probably struggle with that one. Yeah, so we definitely have voice assistants that can impersonate different accents from across the world. Our voice assistants at home, Google Home, your Alexa as well, all have that type of intelligence built within them. Predict how much stock I'll need for my warehouse next month. So supply chain is a huge area that ML and analytics are built within in order to ensure that we're not wasting essential resources in today's society where we have a climate emergency. That is a massive thing to take into consideration. Predict which year the Earth will be too hot to live in, one of my favorites. Yeah, this is definitely an interest of mine. And I think climate science and its capability has grown a lot, more so because of the amount of attention it's getting. So we have a much more diverse approach to answer questions that are extremely, extremely complex and don't have those easy to follow linear paths that a lot of machine learning models can sometimes fall into the category of. So these are the type of problems that we should probably be focusing on. The algorithms where we can understand the theory and essentially program it, they're all great. Yes, we do need to focus on this, but these are the type of problems that really have real world implications for us.
So can I throw it out there? Does anybody think that any of these problems have been solved?
I guess the first one. Most of them are solved.
So I would actually say that if we go back to the previous slide, right? We know the theory and we know the best possible algorithms, right? Each of these, right, is 100% of all of our knowledge, and we know at this point in time we can't improve on them. If we go to the next slide, right, this is where all the accuracy levels and the F1 values and all of the things where you need to tune models come into play, because we haven't solved any of this at 100% like we have the last one. And I think this is where the opportunity comes in, because the closer you get to attaining that generalizable model, right, the more inclined you are to be able to supersede an existing model. And that's why you've got Google, Microsoft, AWS, all these huge companies spending so much money on solving the same problem, because they're trying to, there's a race. They're trying to outmaneuver each other. They're trying to get better and better data sets, trying to find small competitive edges and tweaks in algorithms, use the next best thing to even get like 1 basis point percent to recognize a mountain better, and that's where the innovation comes in, because you have to be clever to do this. You have to understand all the building blocks, right, that everybody else has been doing to recognize a mountain, so that you don't reinvent a wheel and do something a little bit cleverer. But that's the opportunity as I see it. So I guess this is for me where most of my energy was focused, right, on sorts and lists, and and this is how we've transitioned, right? You see, back in 2000, trying to find clever ways of doing binary searches and binary sorts, which is now just available in software. And then 2020, we're talking about things like transfer learning, where we're building on other people's knowledge and we're trying to enrich it. So we talked at the start about that differentiation between software development, software engineering, and data science. And I put a few things down which I feel commoditize, how I think of myself as a software engineer. In that if you know how to put the building blocks into the right place, you can automate anything, and you generally software engineers understand that languages aren't important. You saw object orientation. You heard a little bit about Scala, functional programming languages, Python. You'll find that people that have good software engineering experience will just move from one thing to the other. They'll move from scripting languages to shells to anything because the concepts are there. And we're just building workflows, and we're building workflows to automate things, shape data in the right way, or so that it can get to the last building block, which is a data science building block. Logic's generally not a problem for us, right? We understand logical constructs and binary constructs really well. I got a bit carried away with that one, I think. Use the cloud as the architecture of your own matrix. Big matrix fan. But generally, right, this is now a software playground. You know, you've got vast quantities of compute, networking, you know, amazing capabilities for storage and data, big data in Azure. And it's about putting all these things together at scale and just making things work. When Java was released, I remember actually when Java 1.0 was released, finalizers didn't quite work in them until 1.1. And Sun Microsystems, who owned Java before Oracle, coined the term IJW, it just works. And that was what all software developers used to go around saying all the time, it just works. And that was because they made this sort of first platform independent bytecode interpreter, which could basically run on Linux or on Windows. You know, and as bizarre as it is, nobody had done that before. So you wrote software and you ported it from one platform to another, and it just works. So that's what software engineers are used to doing, just making things work. I don't think you've seen that bit, but I'll hand over to you to try and extrapolate what I was thinking when I was thinking about data science.
Okay, so I might skip this because I think I cover it, unless you want to say something else on it.
Not really.
No? Okay.
So I think I put a slide in just to show that you can't actually do one without the other. You'll find, and I think Darsh got some slides later on MLOps, and MLOps is really great because it shows how you bring software together, because things need to work in a production environment, and how you bring data science thought processes together to actually deliver something that's repeatable for users, because software is all about repeatability as well. And data science is about experimentation and being able to get closer and closer approximations to what you're trying to discover. So putting these two things together, it seems easy, but it's actually not. It's quite difficult to glue them together, but they do work better together. So I guess these are some of the questions that you might end up asking when you build machine learning models. How do I get people to use it? You know, most times data scientists work with Jupyter notebooks, Spark notebooks, but it's a far cry to building a large-scale e-commerce application that predicts who's going to buy what item next. You know, how do you make that happen? You know, what happens if you manage to get your model into production, right? And then you have a whole new set of users and everything breaks and all of your predictions are wrong. You know, you're predicting that somebody's going to buy a blue hat and they bought a red hat, and same thing happens every single time, you know? What do you do? Well, if you've got thousands of people shouting at you because your business is saying all the wrong things being recommended, right? Then you need to work out not how to fix it, but go back to the previous one. And let's see, we just talked about that one. And things like this, which is a very, very, very common, it's a simple expression of data science, right? But the reason that data scientists have so many different measures of what is going on within the model is because it's so complicated. You know, you change one thing and then it has an effect on another part of the model, right? And it seems like you can improve its predictions in a certain way, but then, you know, it will get worse at a different type of prediction, right? In a different space, like different number space that you're trying to predict in the model. So, so it's about really getting across that a lot of these things that you're seeing here have both software engineering and data science answers to them, and the very common things that people ask.
Okay, I'm going to talk a little bit about data science, AI, ML, the full works. But before we do, can I just get an indication from you guys? How many of you are on courses or have an interest that focuses on AI or data science? Okay, quite a few of you. So what are the rest of you up to? Are you focused more on engineering or other areas of tech? Yeah? What kind of areas are you focused on? Sorry, what was that? Okay, full stack development. Okay, cool. Anybody else? No? No. What was that, sorry? Sorry, could you repeat that again? iOS, okay, yeah. Okay, great, cool. Okay, so I'm going to talk a little bit about data science. It is quite a hot topic, I guess, within most industries, and we'll kind of go on to see why. So what is AI and how is it driving innovation? So AI encompasses quite a lot of things. It's been around for a long time. We won't go into the history of it at the moment, but essentially when we're talking about AI generically, we're talking about the ability to mimic human intelligence. And we haven't quite got there. So on the right-hand side there, we have what Richard previously referred to as weak intelligence and strong intelligence. So we're nowhere near artificial general intelligence, which is the ability to mimic all aspects of human intelligence, creativity, the emotional process, etc. And I think once we do, it might be a different ethical conversation, but we're nowhere near there yet. So what do we do have? We have machine learning. So this creates algorithms that can learn from data to make decisions, but they still require human intervention to actually make the outputs of those models useful. And then we have deep learning, things like NLP, image recognition, etc. A lot of that can be done without human interaction, and we can develop systems to kind of take the output of that and make an automated decision. So how is this driving innovation? So if we look at the bottom examples there, Uber, Deliveroo, Netflix, Amazon, Tesla, they all have AI capabilities, and that's enabled them to do things faster, scale, and develop new user experiences. And with that, they have kind of developed new business models. They've redefined industries completely. They're raising standards of living to some degree and progressing towards artificial general intelligence. So when we think of innovation, if we look at synonyms of innovation, we think of change, alteration, revolution, restructuring, rearrangement. So it's not necessarily, it's developing something new out of something that already exists, which is what they've been able to do by looking at different problems with an AI perspective. So AI is here to stay, and there's a lot of kind of facts that you can read about this, but I'll point out a few here. So AI growth is expected to increase GDP by 26% by 2025. So PwC did a study which showed that AI growth will lead to $15.7 trillion of investment. To put this into context, that's greater than both China and India's current combined GDP. There will be 12 million net new jobs. So the World Economic Forum has estimated that 85 million jobs will be displaced, while 97 million new jobs will be created by 2025. This is often a concern when we speak to general public around the capabilities of AI. And I think this is an important thing to recognize, that it is here to stay, and it will displace some jobs that are very structured, very repetitive, don't necessarily utilize the best of our human abilities. And instead is what we should focus on is being able to reskill and essentially empower people to do things that they can put their passions to and kind of utilize those human capabilities in a better way. 22.7% increase in AI accessibility. So over the last kind of couple of years, there's been a massive growth in low code or no code type platforms. And whilst I fundamentally am of the opinion that a lot of in-depth AI innovation still requires a lot of code and theory, I think this is a great tool for people. I think it's great to kind of involve more diverse audiences, more teams to come together to share their ideas and how we can kind of tackle problems from different angles, which I think is always a great thing. Particularly as well for some of the rinse and repeat type scenarios that we've looked at previously, we don't need to reinvent the wheel. If there are things that already exist out there that we can quickly put into production, then we should do that. We shouldn't spend lots of time and resource on reinventing the same thing. So I think, again, the increase in accessibility will also help us accelerate towards our moonshot goals. There are massive kind of emergencies within the health sector and obviously the climate emergency as well. So being able to bring people together to focus more on problems that need our attention, I think will be a great thing too. So on the right-hand side there, I have a history which Rich has kind of hinted to before around kind of the AI winters that had previously occurred, along with where our initial computer was built by Charles Babbage and then first programmed by Ada Lovelace. I won't go through this in a lot of detail because you can kind of see how AI has grown through the timeline, and a lot of courses will go over this. But what I would encourage you to do is if you want to live the history, then please visit the National Museum of Computing, because you actually get to see those computers that were initially built there, and there are some amazing volunteers that can actually bring those stories to life for you as well. So we've covered a few examples of AI previously, but I just wanted to highlight some that are kind of more hot topics. You guys are probably thinking about careers that might be relevant to you, and a lot of people these days don't want just a job, they want to feel like they're contributing towards something good. So I have, I'm also biased because I kind of work in this area, but here we have understanding climate change better. So there are a lot of factors that go into understanding climate change. We don't have the same amount of energy touching each point of the Earth, which is a thing that we need to consider. We have complex weather systems that consist of clouds, our water systems, our human impacted ecosystems that all need to be considered when we're understanding the impact on climate change. So machine learning, AI has huge benefits there. Predicting energy demand, another hot topic, especially within the UK at the moment, with the energy crisis. As we kind of transition to more greener energies, we need to be able to understand how dependent we can be on renewables. So being able to predict energy demand, energy production, and how supply and demand interact there, allow us to kind of make that transition a bit easier. Discovering of new materials, again, solar fuels, being able to design and evaluate chemical structures using machine learning, so developing completely new structures based from theory, and understanding how they might react in the real world is another important application of ML. Optimizing transport, so one of the examples we saw earlier about how do we find the fastest route between 2 points. In a kind of world that is trying to transition towards net zero, we need more of these kind of tools to help people make better decisions, not only to get somewhere faster, but also to release less energy. Lower the barrier to electrical vehicle adoption. This is quite an interesting one. From an ML perspective, there's also a lot of bias that we need to think about in terms of the training data sets that we might use to develop this. So for example, electrical vehicles are currently quite expensive, not they're not affordable for the average person. And if we're looking to increase the infrastructure, we might look to see, well, where do we currently have chargers? Where do we need to expand chargers? And we might have a bias training set in the sense that a lot of affluent areas are likely to have electrical vehicles. And so we'd probably build more infrastructure around those communities rather than thinking around how we can really enhance electrical vehicle adoption. Smart buildings. So IoT is massively taken off in the last couple of years. And this is more and more important. So a lot of you've probably seen in London, Canary Wharf have the lights on every night, which is really annoying. But we need kind of smart systems to be able to say, right, there's nobody in this room, let's turn the lights off. We don't need the heating on. Or even in the case of the summer, which I know Spain have kind of introduced as, well, do we need the room to be ice cold, or what is an acceptable room temperature to have the room so we're not using copious amounts of air conditioning energy as well? Optimizing supply chains. So again, reducing waste. Precision agriculture at scale. This is an interesting one again. As we kind of have used so much of the land that we currently have accessible to us, we need to be able to understand smart ways in which we can reduce pesticides and really toxic chemicals like that to really gain the most out of reusing the land that we do have. Deforestation to tackle law enforcement with illegal activity. I've got a good use case for this one. So Greenpeace used the NASA satellite imagery to actually detect illegal burning of peatlands. So in the UK, if the peatlands are deeper than 40 centimetres, it's illegal to burn them. And they were actually able to track illegal forestry of these peatlands, which are huge carbon reservoirs. I think I read somewhere that it was kind of equivalent to all the forests in UK, France, and Germany. And that's how much carbon is sunk into those peatlands in the UK. So that's a huge amount of carbon that we're then releasing back up into our atmosphere, which is not great. So if we can use these to go full circle and kind of clamp down on this illegal activity, that's a great win for society as a whole. And then advertising recommendations, and this kind of really goes into the whole education piece. Not everybody is a technologist, a climate scientist, etc., that are necessarily aware of such issues. So we need to kind of bring it kind of to the more global society essentially, and understand how can we recommend certain adverts that aren't just based on superficial things that we often see on Instagram, etc., but actually have a positive impact on society. Are there any questions at the minute? No? Okay. So moving on to designing ML models, this is the development lifecycle. Has anybody seen this before? No? Okay, so this is a typical process in which we'd go through. This is actually taken from the Microsoft Docs. If you want to go check it out, it's called the Team Data Science Lifecycle. And it'll give you a whole kind of breakdown of each step. But just to give you an overview, if we are starting with a business problem, for example, I want to optimize my supply chain, and I produce coffee beans, for example. I'd want to understand, well, why do we want to predict this for a start? What's the problem, etc. Then I'd want to know how much data do we have on our suppliers, and what granularity is this? Is the data of good enough quality? Do I need to clean it? Do I need to augment it with additional data sets? Is there a problem in our supply chain where we're getting reduced yields, for example? So that moves on to the data acquisition and understanding phase, which is kind of imperative to make sure we can actually even go through with developing the machine learning model in the first place. A lot of organizations will say, I want to predict this and I want to predict it to 99% accuracy. You can't do that. You're going to overfit your model for a start. So as soon as you productionize it, it's going to be pretty worthless. So yeah, we want to start with understanding what data do we have? Is it good enough quality? If not, we need to get that to a better place, because it's not always going to be the most complex algorithm that gives us the best results, although a lot of people do push towards that, and the return on investment is going to be quite low. The better data sets will always win. and it will also use less energy to train the model. So once we've done that, we want to go on to applying our algorithms depending on the types of problems that we have. They might be classification or regression. And it might not just be a simple case of applying a machine learning model. We need to maybe do some feature engineering, particularly if there are subtle correlations that we saw and we kind of want to alleviate those out in a bit more of a prominent way to really enhance the predictive power of that model. We'd want to do some feature engineering. And then we want to evaluate the model. So not only just in terms of its performance, accuracy is not a great one. I know a lot of grads start with accuracy, but there are many different metrics that we can consider, and they all have pros and cons to them. So taking the time to understand why you'd use one performance metric over another is a good time investment. And then you'd want to do some A/B testing before we go out to productionize this. So particularly with recommendation systems, you might have a group that you want to sample before putting it out to the whole of the Netflix platform, for example. And then you want to carry on to deployment. So this is monitoring of your machine learning model in production. And I can go on about this in a whole different talk because there are quite a lot of complex things that we need to consider. And that is really how we make it useful, because we need to make sure that the model is still performing effectively. There's not any data drift or concept drift that we're not aware of. We haven't built up a lot of kind of dependencies on certain data sets that we don't quite know how they're influencing the predict thing that we're trying to predict. So there is a real importance on monitoring at that end deployment stage and kind of making sure that we're continuously evaluating the performance so that it meets our business needs. So one thing that I would kind of say from my personal experience, a lot of data scientists, particularly grads, tend to kind of focus on specific use cases. I know a lot of courses generally give you very textbook scenarios where it's the Titanic data set or whatever, or it's been perfectly cleaned for you. And what I would say is kind of go outside of the box. Do think like, what else could I use to improve this model? Immerse yourself in the problem and the domain. So if it's recommendations, is there census data you can get that would give you some geographical geolocation activity or insight that can enhance the predictive power, that kind of thing. And also data acquisition. So more and more data scientists are being asked to not just focus on the tiny little part of data science, which is model development, but also the data acquisition and also the deployment. So definitely start with data acquisition, because you're definitely not going to build a model if you don't have the right data. And then feature engineering. So this is probably, I can give you a good example for this. When we were trying to predict how much radiance would come out of a solar farm, we did quite a lot of feature engineering and really immersed ourselves within the problem. So we were thinking things like, well, what is the distance to mountains or cities? Because levels of pollution and cloud formation above mountains can influence how much solar radiance is. It's not just a case of this is our weather forecast and this is how much sunlight we're expected to receive, therefore we have X amount of solar radiance. So yeah, really immerse yourself into the problem and get that's where your creativity can really come out. So if that's the part of the job or role that you're kind of looking for, you can really shine in that area.
So that slide, the one, oh my God, that slide's worse. But this was why I said that data science is really, 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 really hard. There's so many opportunities for this to go wrong. And one of the things I think is really interesting here is you're always about 10 steps ahead of the customer as a data scientist. So that whole customer acceptance thing is a bit of a fallacy anyway. Customers will ask you things with problems that they've been struggling with for years, right? And literally heaven help you if you come up with a real solution. And I'll give you an example of where we did this for it was for a chain of sports stores, and we were given a problem to solve about to predict where to put their next stores to maximize revenue. And we over-provisioned on all of the data that we could get, all the things that Darsh was talking about, census data, demographics, understanding of routes and roads, understanding of internet sales, understanding of competitors' internet sales. We had absolutely everything. And at the end of it, we actually came up with a really good understanding of where the next store should be and didn't know what to do with it. Because they didn't actually know when they asked us to do this that we would solve it, because I hadn't solved it for a decade, and they were just manually working out, sort of back of the envelope calculations about where to put these stores, but somewhat based on intuition, and they had a team that was doing it. And so for us to come along with such a disruptive algorithm and model, just didn't know what to do with it. So they shelved it. So there's this as well. And I wanted to make this point because everything that goes on here is so disruptive, right, and subject to so much organizational change that sometimes companies, organizations, institutions actually aren't ready for where you've come up with much more concrete answers that they just haven't had solutions for years.
Okay, so I know we're running a little low on time, so I will go through this slide pretty quick. So making use of machine learning is a team effort. And I've put this architecture diagram up. So this is also from Microsoft Docs. You can look it up. They have various different architecture recommendations depending on the problem domain. But what I really wanted to highlight here is just the small scale, even though it is the most creative part, and in some may argue quite a lot of the important part as well. Machine learning model development is just a small part to actually make it useful. And in some organizations, you might be lucky enough to have a lot of dedicated roles like data engineers and an infrastructure team, machine learning engineers, etc., to help you kind of implement machine learning models. But in a lot of cases, you won't, and you'll have to do the full life cycle yourself, which is why I'm saying kind of focus on data acquisition, but also the DevOps side as well is really important. ML ops is a really important thing to actually make ML useful for anybody to use it. Otherwise, it just sits in a tiny little silo and nobody knows about any of the great work you've done. So starting on the left-hand side, we have the data estate. So this is where an engineer might come in, land data into your data lake so you can use large amounts of data to develop your machine learning models. At the top on the left, we have the actual model development. So this is that life cycle that I just showed around the exploratory data analysis, the feature engineering, the model development, and the model performance. Then we kind of want to be able to deploy the model. So we want to stage it, test it, make sure it actually works on production grade data that's coming in regularly. And then we want to be able to monitor it. So we'd have our infrastructure team kind of make sure that they set up the relevant repos to make sure that versioning can be kind of controlled, and we can look for a lot of those different problems that we kind of previously discussed. So a lot of organizations are actually still quite, I would say, immature in the grand scale of things, and they don't have any ML ops. So they'll have brilliant data scientists working in silos. As you kind of go up through the hierarchy, you might have DevOps, but no ML ops, in the sense that you can iterate through different versions of training your model, but the deployment isn't there. And then we have automated training and automated deployment, and then you have the full ML ops. But I think it's very important to kind of either bring your mindset to kind of encompass all of those aspects in order to think about the end state and how it's actually going to be used, or very quickly within your teams, make sure you have the right skill set from the get-go. Okay, so just a few tips for anybody that wants to kind of get started with AI. My biggest kind of recommendation would be to learn by doing. So whether it's Kaggle competitions, hackathons, meetups like you guys are already here, or create your own projects and tell the world about them, whether it's on GitHub or blogs, or you want to go give your own talk at a different meetup. Sharing the knowledge, sharing your learning experience helps you not only build up a kind of repo of your experience and what you're capable of, but it helps you build confidence as well and really understand how you can tackle different challenges within machine learning. And then I've referenced 2 Microsoft certifications that you can do. So there is a lot of funding that goes into these. So if you guys go to many different meetups, there are various different cloud skills challenges where you can get kind of vouchers to do these exams for free. And the DP100 focuses on using Azure ML. And I would really recommend that because it not only focuses on the model development, but it also shows you how to productionize really easily. So actually making it usable for somebody. And then AI 102, which is AI engineering. So this is more focused on the out-of-the-box AI capabilities that Microsoft have. So whether you're looking at image recognition or knowledge mining, text classification, all that kind of thing, forms, you can kind of use the different APIs within that particular certification as well. So it will give you a good broad scope of the AI capabilities on the Azure platform, and you can kind of get started implementing some of your own projects. So the last point for us to talk about is the Elastic Cloud Academy. I'll hand over to you for that, Rich.
So we've been around for over a decade now, and we've seen how things have progressed in cloud and data, and this stuff is hard to be able to do, you know, and it takes a lot of like everything's muscle memory, whatever you do, and it's just the same thing when you learn new programming languages, when you learn architectural patterns. And so the way that I like to think about where we're at in cloud and data, because if you start from scratch with Microsoft Azure, right? Microsoft has had thinking on this with like tens of thousands of product engineers since 2008. So it's no surprise that 240 different services later, everybody's confused, right? What goes where? How do you put it together to actually do anything? It turns out there's lots of different ways to do this, right? So people that are trying to do stuff like our customers, they get confused. Microsoft get confused themselves. They have so many different permutations and designs of how to do things, right? They forget which ones work better than others. And so trying to cut through the wheat from the chaff is a learning experience. And this is one of the things that we've built internally, and it's some advice that I want to give you guys, because it's taken us a long time to get to a state within our business so that we can upskill ourselves and upskill our customers to do to learn things in the right way, in a very, very practical way, because otherwise you've just got a sea of information around you. I can't even imagine, right? I don't actually think anybody's done a count of the number of documents for certifications that you've got, on the Microsoft Learn site, but it's probably something utterly horrendous. So if you start from day one going, what do I learn, right? Then you'll be faced with 1 million web pages, right? That's the reality of this. And trying to sift, you know, what is important and what isn't is very difficult. So, you know, I don't want to insult anybody by this line, but you know, it's really important to learn from other people by shadowing. And, you know, that might be initially through an open source activity, you know, and there are tens of open source projects, hundreds of open source projects that you can get involved in where you could learn by example, cloud APIs, for example. So these are some of the things that I've done over the last decade. Similarly, and I think I'm using the word apprentice here very, very loosely because obviously, you know, I think speaking to a room full of university graduates, so, you know, it's a very, very different career prospect to be an apprentice. But when we get engaged in cloud and data, that's how we start, because we fall back more on practical things that we need to be able to do, which are to be able to get code into production, whether or not you're doing engineering workflows or whether or not you're doing data science. It has to be useful to someone. You have to have users at the end of the day. And the best way to learn is through that shadowing, almost like in the traditional world of plumbing or electrician, exactly the same thing. You go through that shadowing process. So that's effectively how we teach internally. And I wanted to just leave you with that sort of last messaging, because whatever you do, whatever jobs that you apply for, however you go through your next skills upgrade, whether it's in a company, whether it's through the Microsoft Learn site, you should try and attach yourself to somebody that has put software into production, especially in the cloud, to do that fundamental learning. Just take it one step away from theory. Okay.
Thanks. Are there any questions? Okay. Thanks, everyone.
Thanks, everyone.
Thank you very much. That was amazing. We've had 2 fantastic sessions this evening. I hope you've all enjoyed it. I'm not going to keep you any longer because it's time to wrap up and go home. But our next meetup is going to be on the 7th of December. It's going to be a big Christmas party. Everybody's welcome, students, MVPs, RDs, the lot, anybody in the community. And of course, if you're watching online, then please do come down in person and you'll get some food. So come along. It's nice having you today. Thank you for coming and enjoy the rest of the evening. Have a